Hello and welcome back to the Jungle Histology online training series. My name is Ken Longenecker and this is the fifth of 9 modules designed to teach anybody who's interested how to perform the methods my colleagues and I use to do rapid reproductive analysis on coral reef fishes. The topic of today's module is size at maturity. This is going to have a little bit different format from the 4 modules that you've seen already. First of all, we're going to take a detailed look at the methods used for microtechnique. Now, you've had a brief overview of these methods previously, but these histological methods are really so important that we want to take an in-depth look at the methodology that you'll be using. The other difference is that we're going to be joined today by a guest, my colleague Ross Langston, who's going to be explaining these methods as he performs them. The steps we're explaining today are going to provide the data that will allow you to fill out these 3 columns of the data sheet. And here's a list of the reproductive information that you'll generate from the data in those 3 columns. So again, I really want to highlight the importance of understanding the methods that we're outlining today. The first thing you'll do is subsample whole gonads. Just to remind you where those gonad samples came from, we're going to step back 1 or 2 steps to the point in whole specimen processing where the gonads have been placed into a sample bag and fixed. Wait at least 24 hours for that fixative to work, and remove the gonads and the tag from the bag. Weigh the whole gonad, record that weight, now take the smaller part of that 2-part tag and put it into one of the wells of a tissue culture plate. Then you'll remove a small subsample of the gonad, no more than 2 millimeters in any one dimension. Put that subsample along with its tag into the well and then add some alcohol to begin the dehydration process. Let's watch that subsampling process a couple of more times. One of the things I'd like you to see here is that we are subsampling from the periphery of the gonad. That is, we're including the connective tissue that's on the outside of the gonad, and that's going to help the subsample remain in one piece as we go through the processing. On the other hand, if you just have a small gonad, all you need to do is take a cross section through the whole organ. Let your subsample sit in the 50% alcohol for at least 20 minutes. The point of that short video was to show you how to take a subsample of the gonad, but I really want to emphasize here that you need to record the whole weight of the gonad before you start cutting into it. Now this is important because that whole gonad weight is going to be used for spawning seasonality and length fecundity relationships. Up until now, the gonads and the subsamples have been stored in water-based solutions. Now we're going to take some steps to remove water from those tissues. And we'll continue the dehydration process by taking the subsamples through several changes of 95% ethanol. Allow the subsamples to sit in this alcohol for at least 20 minutes. Remove that change of alcohol. And replace that with fresh alcohol. And wait at least another 20 minutes. Remove the alcohol. The next step is to prepare some plastic resin that will be used as an infiltration solution. Now this plastic resin is part of a commercially available kit called JB4. The infiltration solution is made from a kit called JB4. We use solution A and a catalyst.
100 mils to 1.25 grams of catalyst. So we're actually going to do 200 mils. And so we're going to put it in there. So this is part A. Measure out exactly 200 mils. Each of these is 50 mils. It's 50. 100. 150. 200. 200 mils. In reality, because you're in a warm condition, you probably don't need 1.25 grams per 100 mils. You can go down to 1.0. So we'll go somewhere in between. This solution will be both for infiltration and will also be for embedding. Just do that. And it'll take a long time to dissolve, so we're just going to leave it in there, mix it around for about a minute, let it sit for a couple hours, come back, see if it still needs to be mixed a little bit more, but you don't want to shake it because that gets air in there. Move it around.
Don't shake the JB4.
Don't shake the JB4.
All right. Now you're going to saturate those gonad subsamples with the plastic resin. Now you'll add that infiltration solution to your subsamples. And just as you did for the alcohol series, you'll wait at least 20 minutes. Remove that infiltration solution.
Okay, so we've got our waste JB4 solution. You can see we've got about maybe 100 mils or so of there in there. So we're going to go ahead and add a couple of mils of the solution B, which is the hardener. And this is just going to let us to more easily dispose of it, since it'll be a solid waste rather than a liquid. So we'll just put a couple in there and then swish it around a little bit. Now, it's important to remember that this is an exothermic reaction. It releases heat, releases, I think, some gas too. So you don't want to screw this lid on all the way. You want to leave a little bit of space after you mix it. Okay. And then the other thing is, don't wait until the bottle's all the way full up with waste to add the hardener, because again, it's exothermic. If you do something like that, it's probably going to expand and shatter the bottle. So I like to harden them, you know, at 200 mil increments or something like that, so it doesn't create too much heat.
Now go back to your subsamples and add more infiltration solution. And you'll wait another 20 minutes. And then remove that infiltration solution. The next step is called embedding, and here you're just going to suspend those gonad subsamples into some hardened plastic. At the same time, this step is going to harden that resin that has infiltrated into the gonad subsamples.
So today we're going to embed the specimens that we had infiltrating. We've gone through 2 changes of 100% alcohol, 2 changes of the JB4 resin, and now we're going to harden that resin and put them in these beam capsules in order to do so. So we load up our tray with 15 beam capsules as well. So we'll load up these 15 capsules. All Alright, now that we've got our JB4 trays loaded up with the beam capsules, we're going to go ahead and load our specimens into there. It's easiest to load all the specimens first before you catalyze the resin and put it in there, because the resin is really only good for about 5-10 minutes or so. So I like to just load these up dry with the specimen and the tag. So for each well I take out the specimen. They should be about a third the size of a pencil eraser or less. Load it in the bottom, just leave it dry, and then put the tag in at the top. You're going to need to curl the tag a little bit, push it down about a third of the way so that it'll be covered with resin. And just make sure that you transfer the tag each time you move the specimen, because if you have a specimen without a tag, it's no good. So we're going to continue doing this, loading up each of the beam capsules with the specimen and the tag, and then when we've done that, we'll come back and we will add the resin, the catalyzed resin, to there and go ahead and harden those capsules. So now that we have all our specimens loaded up in the empty beam capsules, we're going to do the final step, which is adding catalyzed resin, resin that has the hardening agent in there, into the capsules, closing those capsules up so they can harden into stubs that we can section. So again, what we have is our JB4 solution right there, which was 100 mils of the part A plus about 1 to 1.25 grams of the catalyst solution. So that was our normal infiltration solution. The only thing we're going to do different now is take that solution and then we're going to add back to it the hardening agent, which is in the glass bottle here. For this step, you use fresh solution, that you don't use solution that's already been used for infiltration. So it should be fresh solutions mixed up in the last day or two. We're going to measure out 25 mils. And the largest batch you should ever mix up for hardening is 25 mils at a time, because the more solution you put in there, the faster it will catalyze and harden. And now we're going to add exactly 1 mil of the hardener, so 1 mil to 25 mils. And this has to be an exact measurement. Everything else we've done is kind of like cooking. You can have a little more, a little less, but this is really important only to have 1 mil. And so we're using 1 cc tuberculin syringes, adding that in there, and we're not going to reuse these syringes because this stuff tends to melt rubber and stuff like that. So we just put it in there and then wash that out, set that aside, close up the bottle. Now we're going to mix it up a little bit, and very quickly we're going to fill our capsules as full as possible. The idea we want to do is to keep as little air in there as possible, so that when we close them there'll be a tiny little air bubble, but there shouldn't be giant air bubbles in there, because less air, the harder the stub you get. So you get a little tiny air bubble, that's okay. If you get a giant air bubble, it's not okay. Those in our desiccating chamber and let those sit for a couple hours. Ideally, if we have some sunlight, we can put them in sunlight, and that will help them to harden